All right, guys. Number one, apologies for screwing up my timetable and being so late to class that I had to make this video. But let's get through it. So today we're working on using sine, con, and tan to calculate angles of elevation and depression and what these mean, and also learning about bearings, true bearings, and how they're used in navigation and triangulation problem-solving tasks. This is probably pretty much the hardest concept in this chapter, in chapter 18, and it's really important to get it right so that you can successfully apply the easier stuff to this. So by the end of the day, you need to be able to identify angles of elevation and depression. You have to be able to use trig ratios to solve unknown value. So that's your SOHCAHTOAs. You have to draw accurate diagrams to show bearings, and then you have to calculate bearings and side lengths by using both the ratios, SOHCAHTOA, and the sine and cosine rules. And there's quite a few questions there to do. So we're going to work through the worksheet that I've attached on sector. And here it is. So 18E, angles of elevation and depression, bearings and triangulation. So of course, elevation means that it elevates from the horizontal. It goes up. Depression means it drops down from the horizontal. So if you consider your eye level as the horizontal, that might make it easier for you. Be aware sometimes you have to account for a person's height when you're dealing with a question. So sometimes you use your SOHCAHTOA to find the height of a building, but then you have to remember to add the 1.5 meters at the end for a person's height. So be wary of that. So you still do the same steps. You still have to draw your situation. You still have to put on the information you know, including side lengths and angles, and make sure you label it using opposite, adjacent, and hypotenuse. You've got to figure out your relevant sides, use that to select the appropriate ratio, and then substitute your information into it, and then solve. So really the hardest bit is drawing up your situation, because once you've got that done, the rest of it's year 9 maths. So let's do this example. Right, a helicopter is hovering at an altitude of 2,500 meters. Oh, look, there's telling me about the class that I missed. The angle of elevation from the helipad to the helicopter is 35 degrees. Find the horizontal distance of the helicopter from the landing pad to the nearest centimeter. So let's draw that up. So we've got a helicopter. There he is. There's my little helicopter. Doesn't he look fantastic? And he is 250 meters in the air. I would use a ruler if I had that function on this app. The angle of elevation to the helicopter is 35 degrees. So I'm going to draw up my little right angle triangle. There's the right angle. And I'm going to put my 35 degrees in there because it says elevation. So that's the difference between the horizontal up. Next step is we've got to label it. So that's our hypotenuse, that's our opposite, and that's our adjacent. We are looking for our adjacent, and we've got the opposite, so we're going to be using tan. So that's the tan of theta equals the opposite over the adjacent. So the next step we need to do is to fill in the information that we have. So we have tan 35 equals, the opposite is 250 over, well, we don't know the adjacent, so we're going to leave that as A. Now, a little shortcut with when you have a formula like this and the value that you're looking for is on the bottom, you can just directly swap it with what's in the equals. So we can rewrite it as A equals 250 divided by the tan of 35. And we just go and plug that into a calculator to find the answer. Okay, so there's our answer. It's 357 meters and 0.037. We've got to do it to the nearest centimeter. So it'll be 357.04. Okay, so that answer was in meters, and you can see I just converted it to centimeters there. So 35,704 centimeters. Okay, here's an interesting one. We've got two vertical buildings. There's a 57-meter gap between them. One's 158 meters tall, and the other is 237 meters tall. We need to find the angle of elevation from the shorter building to the taller building correct to 2 decimal places. So let's start by drawing it up and then we'll find a right angle triangle. Again, no ruler. Sorry guys. So this is our taller building. This is our shorter building. You can see the 237 meters and the 158 meters for both buildings. There's our 57-meter gap in the middle. Now we want the angle of elevation. I'm trying to indicate it here with theta from the smaller building to the taller building. So to do that, we need 2 sides and we only have 1, but we can work out this side quite simply by finding the difference between the 2 buildings. To do that, we just subtract 1 from the other and we get, calculator's working, 79 meters. Okay, so there's the 79 meters. I've redrawn the triangle just clear of all the buildings, just so it's easier to see and to visualize. What we've got to do now is we've got to go in and label what we have. So there's our angle. That means that this is our opposite. Oh, that's a terrible column. This is our opposite and this is our adjacent. So again, we're using tan. Tan theta equals opposite over adjacent. Let's fill in what we know. We don't know the angle, but we do know that we have 79 over 57. We need to get the angle by itself, so we're going to use the inverse of tan to get that. Okay, and that's what I'm going to plug into the calculator. Okay, so here we are. I've typed in inverse tan 79 over 57 and I get 54.1888 meters. Sorry guys, it's not meters, it's degrees, and of course I have to round it off to 58.19 because the answer wanted to 2 decimal places. So as you can see, that's all very much year 9 trigonometry again. The problem is you've just got to make sure you draw your picture right and then it's all easy. Time to move on to something much more difficult. So we're looking at bearings, and we normally call these true bearings with a little capital T after the degree marker, and they're measured clockwise from the north. Now clockwise means it goes that way. They're always written with 3 digits. So here we have an example. We don't say 45 degrees, we write 0.45 degrees T. Opposite direction, so if let's say you were going northeast and then you turn around and face northwest, you could find that the difference between the 2 values is 180. So 45 plus 180 gives you 225. We've also included this diagram on the notes for you because it shows you all of the degrees, so it might help you with drawing triangles. All right, our first example is we have a ship traveling due south for 5 kilometers and then they change direction to go on a true bearing of 120 degrees for 11 kilometers. Now, we don't have anything to work out yet. We're just going to work on drawing it. So, to help you with spacing it, we'll go back to this diagram. Now, due south is obviously this direction, but then it changes to a direction of 120 degrees. So that's 120 degrees there. So the ship's basically going to go like this and then like that. Let's go and try and draw it properly. Again, no ruler. I'm going to try and do this as steadily as possible, guys. So we go south for 5 kilometers, and I've probably made that a bit long. I'm just going to raise a bit of it because I don't want to go off the page. And then we're going to go on a bearing of 120 degrees, which we think is about that, using a little compass above, for 11 kilometers. So we just write our lengths on that. Sometimes when you're doing this, it helps if you just put, where north is, just to help you, funnily enough, keep your bearings. Okay, A wants you to find out how far east the ship is from a starting point, correct to 2 decimal places. Now, there is more than one correct way to solve this, but after having a little think, this is how I want to do it. I'm going to draw an imaginary line in blue that continues on down in a southerly direction because that doesn't waver east or west. And then the line that I'm actually looking for is this line here. Okay, so that's going to be what we're looking for. Now, obviously, we've got a triangle. We've only got one piece of information so far, and that's a hypotenuse of 11 kilometers. But if you think about it, you've actually got two pieces of information, because if you look here, you know that this angle in here is the supplement to 120 degrees. The supplement means what would take it up to 180 degrees. So 120 plus 60 degrees equals 180. Now, I've got 2 points of information to work out my triangle with. Okay, so I've got my triangle, I've got my information, I'm going to label some sides. So this is my hypotenuse, this is my opposite, and this is my adjacent. I have a hypotenuse, I'm looking for my opposite, so I'm going to use the sine ratio. Sine theta equals the opposite over the hypotenuse. We have got a sine of 60 degrees. We don't know our opposite, but it was 11 kilometers for the hypotenuse. I nearly wrote h again. So let's plug that in our calculator. Actually, before I do that, I'll just quickly rearrange the equation so I know what I'm typing in the calculator. I want to get rid of the 11, so it's going to become 11 times the sine of 60. Okay, so I'll just type this straight in. 11 times the sine of 60, and I get 9.52628. I wonder what I have to round that up to. Okay, so this ship has travelled east from its original starting point, 9.53 kilometres. Now we have to find out how far south it went. So back up to that triangle. Okay, so we're going to have to add 5 kilometers to whatever the adjacent is here, and I'm going to use the cosine ratio to find out the adjacent. Do make note, however, that I could also use Pythagoras' theorem to find the adjacent. Okay, so I'm going to be good and write out my ratio that I'm going to use, and then I'm going to substitute 60 degrees equals the adjacent over 11 kilometers. Rearrange that for the calculator. The adjacent is going to be 11 times the cos of 60. Let's see what that is on the calculator. Okay, that's 5.5 kilometers. So let's add that on. Now our adjacent is 5.5 kilometers, but that's not our total amount south. Our total amount south was actually that 5.5 plus the original 5 kilometers. So that means the answer is 10.5 kilometers. Okay, a yacht sails from point A on a bearing of 38 degrees for 3,000 meters and then switches to 318 degrees for 3,300 meters. It reaches point B. So I'm going to have a go at drawing that. So here's point A. Here's our starting point. We're going to go 38 degrees. So we draw a little bearing. That's directly north. I'm going to say 38 degrees is about that way. And that's 3,000 meters. Then we draw ourselves another little bearing thing with directly north, and we think, what way is 318 degrees? And it's roughly this direction. And we go that for 3,300 meters. And then we call this point B. Okay, it doesn't have to be super accurate, but it does help if you draw those little things in. Don't forget to add your bearings. So that's 0, 38 degrees. And from here to here is 318 degrees. They're both true bearings. Right, the first question wants you to find the distance between A and B, correct to the nearest meter. You don't have a right angle triangle, so we're going to have to use either the sine rule or the cosine rule. Let's figure out what we've got. To me, it's really obvious that we have two sides and a non-included angle, so that means we can use the sine rule. And doing that will give us this angle. Once we have those two angles, we can work out the third angle, which then will let us work out the side. So it's a bit of a long one, this one. So what I'll do is I'll stop this video and put it on a second video.